Hello guys, welcome back to another video. So today we have a problem on integration and it involves some trigonometric functions. So let's jump to the problem itself. The problem says integration of tan x by tan square x plus tan x plus 1 dx. That's what we have to evaluate, right? So how are we going to approach it? So some of you who have watched our previous videos might remember this technique that we were using to solve the partial fraction, one question which involves a method or approach of the partial fractions and how we solved it by the wizard method using a shortcut, right? By adding and subtracting few terms to the numerator. A similar kind of approach I'm going to use here. So let me show you. And meanwhile, you can pause the video and give it a shot and come back later and see the whole solution. So I assume that you would have given it a serious try. Now let's begin with the solution. So if we see here it is tan x, right? Here it is tan x. So can I in the numerator can I make this term, this whole term? I can easily make it. How? By adding and subtracting this tan square x plus 1, right? So what I'm gonna do is tan x was previously there, right? And I'm gonna add this and subtract this. The rest of the things were like that. Okay, wait. Right. All right. So we will club this part. We will club this part and separate this part. This part. Okay. So on clubbing, this part will cancel with these, right? Or the whole of it. So that would be 1 dx plus, or rather say minus tan square x plus 1, and in the denominator it stays the same here, right? Dx. So what will this give us? This will give us x, right? Okay. And what is this? This is sec square x. If you know a little bit of trigonometric identity, so 1 plus tan square x is sec square x. So if here, let's say here, if we make a substitution, okay, what is the substitution? Let's put tan x to be z, okay, then sec square x dx would be dz, okay. So that becomes, and in the numerator you can see this is nothing but sec square x, right? So great, this would simply evaluate to this thing and you can do this. Now this is a very general form of integral, okay, and we will use the completing square method to evaluate this. Completing square method. Completing square method. How are we going to do that? So it would simply become like this. It would simply become like z plus half the whole square plus 3 by 4, and that evaluates to 2 by root 3, because what is this? This is root 3 by 2 the whole square, right? And we know one thing, that integration dx x square plus a square is equal to 1 by a tan inverse x by a, right? We know this thing. Great. All right. So this will give us 2 by root 3 tan inverse z plus half root 3 by 2. So finally the answer becomes, like here this one was x and this one this term. So finally the answer would look like x plus 2 by root 3 tan inverse z plus half root 3 by 2, right? And what was z? What was z? Z was tan x. All right. So let's erase this here and simply write here tan x. And don't forget the constant of integration. Always put this in the answer. Without it, the solution won't be evaluated to be the correct solution. So thank you for watching.